Tunisia, March 19, 1943. A German weapons testing facility outside Bizerte. Hauptmann Friedrich Weber stood in the observation bunker, watching his technical team examine the captured American machine gun with the kind of methodical precision that had made German engineering famous across 2 continents. The weapon sat on its tripod in the center of the firing range, its dark metal still showing traces of desert sand. American markings were clearly visible on the receiver. Serial number 317421, manufactured by Colt's Patent Firearms in Hartford, Connecticut. Weber's orders from Waffenamt, the German Army Weapons Agency, were explicit. Test the American Browning M250 caliber machine gun to failure. Document its performance characteristics, identify its weaknesses, and determine whether German forces should prioritize capturing these weapons or destroying them in place. The testing protocol called for sustained fire until the weapon failed. Standard procedure. The Germans had done this with captured Soviet machine guns, British weapons, even American .30 caliber Brownings. Every weapon had its breaking point. The question was simply where that point fell. What happened over the next 4 hours would fundamentally alter German understanding of American industrial warfare. Not because the Americans had built something sophisticated, not because they had achieved some breakthrough in metallurgy or engineering, but because they had solved the problem of sustained fire through brutal, elegant simplicity that made German technical excellence irrelevant. The mathematics were straightforward. Fire enough rounds through any machine gun and thermal physics would destroy it. The Germans knew this. They had built their doctrine around it. Careful fire discipline, measured bursts, barrel changes, conservation of ammunition. These weren't just tactical preferences. They were necessities dictated by the material limits of steel under thermal stress. What Weber's team was about to discover was that the Americans had approached the problem from a completely different direction. They hadn't tried to build a machine gun that wouldn't overheat. They had built a machine gun that could overheat and keep firing anyway. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The German experience with machine guns in World War II was built on 2 decades of evolution and refinement. The MG-34 had entered service in 1934, a general-purpose machine gun that could serve as both a light infantry weapon and a sustained fire heavy weapon depending on how it was mounted. Rate of fire was approximately 800 to 900 rounds per minute. Excellent weapon by any standard. Quick barrel changes, reliable feeding, effective to 1,000 meters. Then came the MG-42 in 1942, improving on the 34's design with a rate of fire reaching 1,200 rounds per minute. Allied soldiers called it Hitler's buzzsaw because of the distinctive ripping sound it made. That sound alone had psychological impact. German machine gun doctrine was sophisticated. Every infantry squad organized around the machine gun. The gunner was the most important man in the squad. Everyone else supported him. Ammunition bearers, spotters, riflemen providing security. The MG-42 could theoretically fire 1,200 rounds per minute, but in practice, no crew actually fired at that rate for long. The barrel would overheat catastrophically after approximately 250 rounds of sustained fire. German doctrine therefore emphasized kurzer Feuerstoß, short bursts, 5 to 7 rounds, then pause, assess, fire again. This conserved ammunition, maintained weapon reliability, and prevented barrel failure. Every MG-42 crew carried spare barrels and trained extensively on barrel changes. The procedure could be completed in approximately 6 to 8 seconds by an experienced crew. This allowed sustained defensive fire by alternating barrels, one barrel firing while another cooled. Textbook German efficiency. The problem was that this doctrine assumed everyone else operated under similar constraints. The Germans had fought the British, who had their own ammunition limitations. They had fought the Soviets, who had massive amounts of ammunition but whose machine gun designs were not significantly better than German weapons. Then they encountered the Americans in North Africa and discovered that all of their assumptions about the material limits of warfare were wrong. Weber had been on the Eastern Front. He had seen Soviet machine gun positions destroyed after extended firing caused barrel failures. He had seen British positions go silent when ammunition ran low. He expected the American .50 caliber to follow similar patterns. The weapon looked conventional enough. Recoil-operated, belt-fed, air-cooled barrel. Nothing revolutionary in the design. American weapons tended to be simple, he thought. Crude even, mass-produced rather than precision-crafted. That was the German assessment. The testing began at 0900 hours. Weber's technical sergeant, Feldwebel Richter, had 20 years of experience with crew-served weapons. He had personally tested dozens of captured weapons from 3 different armies. He positioned himself behind the M2, adjusted the grip, and checked the ammunition belt. The Americans had left approximately 600 rounds in the ammunition box when they abandoned the position, more than enough for initial testing. Richter opened fire. The sound was different from German machine guns, deeper, more of a rhythmic thumping than the high-pitched hammering of the MG-42. The recoil was substantial but manageable. The weapon fired at approximately 450 to 500 rounds per minute, slower than the MG-42, much slower than the MG-34 in light configuration. German observers noted this in their test logs. Rate of fire appeared inferior to German equivalents, but something else caught Weber's attention immediately. The weapon was extraordinarily smooth. German machine guns had a certain mechanical violence to them. You could feel every moving part cycling. The American gun had a rolling, continuous rhythm that felt almost leisurely by comparison. Richter fired 100 rounds in controlled bursts. Paused, examined the barrel, noted the temperature rise, fired another 100 rounds. The barrel was heating as expected. Standard physics applied to American steel, the same as German steel. At 300 rounds, Weber expected Richter to call for a barrel change. The barrel would be approaching critical temperature. Continuing to fire would risk accuracy, degradation, and potential structural failure. Richter kept firing. 400 rounds, 500 rounds. The barrel was visibly hot now. Heat shimmer distorted the air above the weapon. The metal was taking on a dull reddish color that indicated temperatures well above 700 degrees Celsius. Still, the weapon fired. Every round chambered smoothly, every round ejected cleanly, no stoppages, no misfires, no failures of any kind. At 600 rounds, the captured ammunition was exhausted. Richter cleared the weapon and stepped back. The barrel was radiating heat like a stove. Touch it, and you would lose skin. But the weapon had not failed. Weber's initial assessment noted sustained fire capability superior to intelligence estimates. The weapon had fired 600 rounds without barrel change and without failure. This exceeded the performance of the MG-42 by a factor of approximately 2.4. Interesting, but not revolutionary. Many weapons could fire 600 rounds if you were willing to accept barrel damage. Weber ordered his team to mount fresh ammunition and continue testing. The Germans had brought additional .50 caliber ammunition captured from other American positions, approximately 3,000 rounds total, more than enough to test the weapon to destruction. The second firing sequence began at 09:45 hours. Richter settled behind the weapon again and opened fire. Another 600 rounds cycled through the mechanism. The barrel temperature climbed higher. The weapon continued firing. At 1,200 rounds total, Weber stopped the test and called for a detailed barrel inspection. His metallurgist, a civilian technical expert attached to Waffenamt named Dr. Ernst Kaufmann, removed the barrel and examined it carefully. Surface discoloration, consistent with extreme heat exposure. Slight thermal expansion visible in precise measurements, but no warping, no cracking, no structural compromise. Kaufmann measured the bore diameter at multiple points. Variation was within acceptable tolerances. He checked the rifling grooves. Minimal erosion. The headspace measurement, the critical gap between bolt face and barrel, had expanded slightly from thermal expansion, but remained within functional specifications. Kaufmann looked at Weber and said something that appeared in the official test report filed with Waffenamt on March 23, 1943. Herr Hauptmann, This barrel should have failed. The temperature exceeds the design limits of any German machine gun barrel I have tested, yet the weapon remains functional. The Americans have achieved something I do not understand. Weber ordered testing to continue. At 1,500 rounds, the barrel finally showed signs of accuracy degradation. Rounds were no longer grouping tightly, but the weapon still functioned. No mechanical failures. At 1,800 rounds, approximately 4 minutes of continuous trigger time at the weapon's rate of fire, Weber called a halt. Not because the weapon had failed. Because his team had run out of captured ammunition. The M2 had fired 1,800 rounds through a single barrel without changing it, without catastrophic failure, without the weapon becoming inoperable. German doctrine called for barrel changes every 250 rounds. The Americans had just demonstrated sustained fire capability more than 7 times greater than what German weapons could achieve. This was not a small incremental improvement. This was a fundamental difference in capability that had profound tactical implications. Weber's report to Waffenamt, dated March 23, 1943, classified as secret, was unusually blunt for a German technical document. The American .50 caliber machine gun represents a significantly greater threat than previously assessed. The weapon's ability to sustain fire without barrel changes means that American defensive positions can maintain continuous suppressive fire at rates German infantry cannot counter using standard assault tactics. Recommend immediate tactical adjustments when attacking American positions, confirmed to be equipped with these weapons. But this was just one test, one captured weapon. Weber's report circulated through Wehrmacht headquarters in Tunisia, but did not trigger immediate doctrinal changes. The Germans had more pressing concerns in March 1943. The Afrika Korps was collapsing. American and British forces were closing in from multiple directions. Rommel had been evacuated due to illness. The entire German position in North Africa was disintegrating. One report about one machine gun seemed relatively insignificant in the larger strategic disaster. Then German soldiers started encountering these weapons in combat, and the tactical reality proved even worse than Weber's testing had suggested. Because the Americans had not just built a reliable machine gun, they had built an entire system around that gun. Industrial production at scales the Germans could not match. Ammunition production at rates the Germans found incomprehensible, and tactical doctrine that treated sustained automatic fire not as an exception, but as standard procedure. April 17, 1943. Hill 209 near Longstop Hill, Tunisia. Oberleutnant Klaus von Schroeder commanded a reinforced infantry platoon, tasked with taking an American defensive position, blocking the road to Mejez el Bab. The position was held by elements of the American 1st Infantry Division. Intelligence estimated approximately 30 to 40 American soldiers. Standard defensive position. Von Schroeder's force numbered 85 men. Professional soldiers, veterans of Poland, France, and 2 years on the Eastern Front. The tactical math favoured the Germans. Or should have. The attack began at 0530 hours with a preliminary artillery barrage. 6 minutes of concentrated fire from German 105mm howitzers. Then the infantry advanced in textbook fashion. First squad providing covering fire, while second squad advanced. Leapfrog tactics, professional execution. At 200 meters from the American position, the Americans opened fire. Von Schroeder's after-action report, filed on April 19th after his evacuation to a field hospital with shrapnel wounds, described what happened next with clinical precision that barely masked his shock. The volume of fire was unlike anything encountered previously. Multiple automatic weapons firing simultaneously with no apparent concern for ammunition conservation. Tracer fire visible even in daylight conditions. My leading squads were pinned immediately. Forward movement became impossible. Attempts to maneuver were met with immediate engagement from multiple positions. The fire was continuous, not bursts, continuous. As if the Americans had unlimited ammunition and weapons that would not fail. Von Schroeder attempted to flank the position. Standard tactic. Fix the enemy with frontal fire while assault elements moved around the flanks. His flanking element ran directly into what the Germans had not anticipated. The Americans had positioned .50 caliber machine guns to cover the flanks specifically. overlapping fields of fire, interlocking kill zones. The kind of defensive planning that required both tactical sophistication and complete confidence that your weapons would not fail when you needed them. The German assault broke down after 40 minutes of sustained combat. Von Schroeder had taken 32 casualties, killed, wounded, or combat ineffective. His force was no longer capable of offensive action. The Americans were still firing, still in position, still fully combat capable. Von Schroeder withdrew and called for artillery support. The position was eventually bypassed rather than assaulted directly. Too expensive, too well defended. The Americans were learning how to use their weapons. Similar reports filtered back from across the Tunisian front throughout April and May of 1943. German infantry encountered American positions that could sustain defensive fire at rates that made traditional assault tactics suicidal. Experienced German squad leaders, men who had successfully assaulted Soviet positions and British strongpoints, found themselves unable to close with American defenders because the volume of fire never slackened. There was no lull, no pause, no moment when ammunition ran low and the defense weakened. The Germans adapted. They started requesting artillery support for every American position. They avoided frontal assaults. They tried infiltration at night. They used smoke to obscure American observation. Some of these tactics worked, but they all required additional time, additional resources, and acceptance of higher casualties than German forces could sustain. The Afrika Korps surrendered in May 1943, 250,000 Axis troops captured, the entire German position in North Africa eliminated, but German intelligence officers spent considerable time interrogating American prisoners and examining captured American equipment. The 50 caliber machine gun received particular attention. German weapons specialists discovered several facts that explained the weapon's extraordinary performance. First, the barrel design. The Americans used SAE 4150 chromium molybdenum steel, similar to, but not identical to German barrel steel. The American heat treatment process produced a microstructure that maintained tensile strength at higher temperatures than comparable German steels. This was not revolutionary metallurgy, just good engineering, careful material selection, proper heat treatment. But the cumulative effect was a barrel that could handle sustained fire without catastrophic failure. Second, the barrel was heavier than necessary. German engineers prided themselves on efficiency. Minimal weight, maximum performance. The American barrel was simply massive, 26 pounds of steel where a German barrel might use 18 or 20 pounds. That extra mass served as a thermal reservoir. It absorbed heat more slowly. It took longer to reach critical temperatures. It was less efficient in terms of weight per performance, but it was far more effective in terms of sustained fire capability. Third, the ammunition. American 50 caliber ammunition used a very specific powder formulation that produced consistent pressures and consistent velocities across a wide range of temperatures. German ammunition was excellent, but it was optimized for different priorities: precision, consistency, efficiency. American ammunition was optimized for mass production and reliability under adverse conditions. Good enough for purpose, good enough to work every time, even if not theoretically optimal. Fourth, and this proved most significant, the Americans had built the production infrastructure to make these weapons in staggering quantities. The Germans captured American supply documents during the Tunisia campaign. What those documents revealed was almost unbelievable. American production of 50 caliber machine guns exceeded 150,000 per year by 1943. Total wartime production would eventually exceed 2 million units across all variants. 2 million. The entire German machine gun production for the war, all types combined, was approximately 1 million units. The Americans were building 50 caliber machine guns alone at twice the rate Germany built all machine guns of all calibers, and ammunition production was similarly overwhelming. American 50 caliber ammunition production exceeded 3 billion rounds during the war. 3 billion. The Germans fired approximately 5 billion rounds of all calibers combined throughout the entire war on all fronts. The Americans were producing 3 billion rounds for just one weapon system. The scale was beyond anything German planning had anticipated. This became clear as German forces retreated from North Africa to Sicily to Italy. American firepower did not decrease, it intensified. Every position had multiple 50 caliber machine guns, every vehicle mounted at least one. American supply lines kept ammunition flowing even to forward positions. German soldiers learned to recognize the sound of the 50 caliber, the deep, rhythmic thumping. That sound meant suppression. It meant you stayed down. It meant any attempt to maneuver would draw immediate fire. The psychological impact accumulated over time. German infantry veterans of the Eastern Front thought they understood firepower. The Soviets would mass machine guns and artillery in devastating concentrations. But Soviet attacks came in waves. There were lulls, pauses, moments when German forces could regroup and counterattack. Fighting Americans was different. The fire was constant, professional, disciplined in placement but overwhelming in volume. American machine gunners would fire at suspected positions, not confirmed targets, suspected positions, tree lines, stone walls, buildings, anywhere an enemy might be hiding. This reconnaissance by fire tactic consumed vast amounts of ammunition but achieved psychological effects beyond the physical casualties. German soldiers learned that concealment was not safety. You might be hidden from American observation, but if Americans suspected your position might contain enemy forces, they would fire at it, and the 50 caliber could penetrate most cover, stone walls, wooden structures, light earth berms. The massive projectile simply punched through obstacles that would stop rifle fire. The scale of American ammunition expenditure in Normandy was documented by logistics units. A single American infantry division in active combat consumed approximately 400,000 rounds of 50 caliber ammunition per week. Normandy, in June and July 1944, saw approximately 13 American divisions in sustained combat. That meant approximately 5 million rounds of 50 caliber ammunition fired every week. The Germans could not match this expenditure. German ammunition logistics were chronically inadequate. Delivery was irregular, quantities were insufficient. German machine gun crews learned to fire carefully because resupply was uncertain. American crews fired freely because resupply was guaranteed. This difference in logistics philosophy reflected deeper differences in industrial capacity and strategic priorities. Germany was fighting on multiple fronts. Resources were divided. Every kilogram of steel allocated to ammunition was a kilogram not available for other uses. Choices had to be made. Trade-offs accepted. The United States was geographically secure. Industrial capacity was not threatened by enemy action. Resources could be allocated based on military effectiveness rather than desperate necessity. If American forces needed ammunition, American industry would provide it. The supply chain worked. The psychological impact on German forces was cumulative and devastating. A German soldier in Normandy knew that American ammunition supplies were effectively unlimited. This knowledge affected every tactical decision. Should you attempt to assault an American position, American defenders would have enough ammunition to maintain suppressive fire throughout your approach. Should you defend your current position, Americans would fire enough ammunition to destroy the position, regardless of how strong it appeared. Should you attempt to infiltrate at night, American forces used reconnaissance by fire extensively at night, saturating suspected positions with automatic weapons fire. Every tactical option involved accepting that American firepower superiority would be a factor. You could not outshoot Americans. You could not suppress American positions effectively because they had more machine guns and more ammunition. You could not wait for Americans to run low on ammunition because they never did. Traditional infantry tactics assumed both sides operated under similar material constraints. That assumption was invalid against American forces. The breakout from Normandy in late July 1943 demonstrated what happened when American firepower doctrine applied to mobile warfare. Operation Cobra began July 25 with massive aerial bombardment, followed by American armored and mechanized divisions punching through German lines. The breakthrough succeeded partially through the weight of the initial bombardment, but primarily through sustained exploitation. American columns advanced rapidly. When they encountered German resistance, they would suppress with automatic weapons, fire, maneuver around, and continue advancing. The 50 caliber machine guns, mounted on every vehicle, meant that American columns could engage threats without stopping. German forces attempting to establish defensive positions or ambushes would take fire from multiple vehicles in rapid succession as American columns passed their positions. This made effective German defense almost impossible. You could prepare an ambush position. You could engage the first few American vehicles, but then every subsequent vehicle would fire at your position as it passed. Within 30 seconds, you would be taking fire from 20 or 30 50 caliber machine guns plus vehicle main guns. The ambush position would be destroyed before you could disengage. German forces attempting to retreat in front of American advances faced continuous harassment. American armor would advance down roads at combat speed. Vehicle commanders would maintain 50 caliber fire on flanking terrain continuously. This reconnaissance by fire meant that any German soldier or vehicle within a few hundred meters of the road was at risk. German columns attempting to retreat would be engaged by American fighter bombers during daylight and by American armored patrols at night. The combination made organized retreat difficult. Units became scattered, equipment was abandoned, cohesion broke down. By August 1944, American and British forces had encircled large German formations in the Falaise pocket. Approximately 50,000 German soldiers were captured, perhaps 10,000 to 15,000 escaped. But equipment losses were catastrophic. The Germans lost approximately 500 tanks and assault guns, thousands of vehicles, and most of the heavy equipment of 7 armies. The German army in France was effectively destroyed as a fighting force. Some units maintained cohesion and conducted fighting retreats to the German border, but the offensive capability of the Wehrmacht in the west was permanently broken. The retreat across France in August and September 1944 revealed the full strategic implications of American firepower superiority. German forces were not simply defeated in battle. They were pursued relentlessly by an enemy that could maintain combat operations continuously because ammunition and supplies never ran short. The 50 caliber machine gun became the symbol of this relentless pressure. You could hear American columns advancing from kilometers away, the distinctive sound of 50 caliber fire, continuous, methodical. Coming closer, General Major Rudolf Christoph von Gersdorf served as Chief of Staff for the 7th Army during the retreat from Normandy. He survived the war and provided extensive testimony to American military historians. His assessment of American tactics was remarkably candid. We understood that we were beaten, not beaten in the sense that we lacked courage or skill, beaten in the sense that we lacked the material resources to continue effective resistance. American firepower was overwhelming. Their 50 caliber machine guns were everywhere, on every vehicle, at every position. They fired continuously. That sound and knew what it meant. It meant Americans were advancing. It meant resistance was futile. It meant casualties without purpose. Unit cohesion depends on soldiers believing their actions can affect outcomes. When facing American firepower, soldiers increasingly believed nothing they did would matter. The Americans would simply fire until resistance stopped. The pursuit across France demonstrated American logistical capability at operational scale. American armored divisions advanced hundreds of kilometers in weeks. They maintained combat operations throughout. They never paused for extended periods due to ammunition shortages. The Red Ball Express, the massive truck convoy system that supplied American forces, delivered thousands of tons of ammunition daily. 50 caliber ammunition was a substantial portion of that tonnage. Each round weighed approximately 4 ounces, including the brass case and projectile. 1,000 rounds weighed approximately 250 pounds. 1,000,000 rounds weighed 125 tons. American forces in France were firing millions of rounds per week. The logistics required to sustain this expenditure were staggering. German logistics, by comparison, were collapsing. The retreat from France destroyed most of the Wehrmacht's transport capability. Thousands of trucks were lost. Fuel supplies were captured or destroyed. Railway infrastructure was systematically targeted by Allied air power. Even when ammunition was available in Germany, getting it to frontline units became nearly impossible. German soldiers fought with whatever ammunition they carried. When that ran out, they surrendered or died. There was no resupply coming. This knowledge affected morale more than any tactical defeat. The German border, September 1944 through December 1944. American forces reached the Siegfried Line, Germany's western defensive fortifications, in early September. The pursuit slowed. German defenders were now fighting for their homeland. Resistance stiffened. The easy advances of August ended, but American firepower doctrine continued to prove effective even against prepared fortifications. The Siegfried Line bunkers were designed to withstand artillery fire. Thick concrete, interlocking fields of fire, professional defensive engineering. American forces attacked these positions using combined arms tactics that integrated 50 caliber machine guns into every phase of operations. The standard American approach to bunker assault involved suppression, maneuver, and destruction. 50 caliber machine guns provided suppression. Tank destroyers and tanks provided direct fire support. Infantry maneuvered to assault positions. Engineers placed demolition charges. The 50 caliber fire was critical during the suppression phase. Bunkers had firing ports and observation slits. These openings were necessary for defenders to see and engage attackers, but they were also vulnerabilities. American 50 caliber machine guns would concentrate fire on these openings. The massive projectiles could not penetrate the concrete, but they could make it extremely dangerous for German defenders to observe or fire through the ports. A 50 caliber round impacting near a firing port would send concrete fragments and spalling into the bunker interior. The noise was overwhelming. The psychological effect of sustained 50 caliber fire striking your position was profound. German defenders described feeling trapped. The bunker protected you from most threats, but it also confined you. You could not maneuver. You could not retreat easily. You had to stay in position, while American fire methodically suppressed your ability to fight back. Eventually, American infantry would close with the bunker and destroy it with demolitions or flamethrowers. The 50 caliber fire continued throughout, preventing German defenders from engaging the assault teams effectively. Lieutenant Wolfgang Fischer commanded a bunker position near Aachen in October 1944. His position held for 3 days before being overrun. He survived and was captured. His interrogation, preserved in American military archives, provided detailed insight into the German experience of being subjected to American firepower. The Americans fired continuously at our position, day and night. The 50 caliber rounds made a distinctive sound when they struck concrete, a deep, hollow boom. Then fragments would spray into the bunker. We could not observe safely. Anyone who looked through the firing ports risked being hit by fragments or by direct fire. We were blind. We could hear American infantry moving outside, but could not engage them effectively. When they finally assaulted, we had no ability to defend. Half my men were wounded by concrete fragments before the Americans even reached the bunker. American manufacturing philosophy reinforced the design advantages. The United States had massive industrial capacity and used it to build weapons at scales other nations could not match. But American manufacturing also emphasized interchangeability and quality control. Every M2 produced by any manufacturer would accept parts from any other M2, barrels, bolts, springs, all interchangeable. This meant logistics were simplified. Any spare part would work in any weapon. Field maintenance was practical because you did not need manufacturer-specific parts. German manufacturing, by contrast, emphasized precision craftsmanship. Each weapon was assembled by skilled workers who fitted parts individually. This produced excellent weapons. But it meant parts were not always interchangeable. A bolt from one MG42 might not function perfectly in another MG42 without adjustment. Field maintenance required trained armorers. Spare parts logistics were complicated because different manufacturers produced slightly different variants. The result was that German weapons performed excellently when properly supported but degraded faster when logistics failed. By 1944, German logistics were failing consistently. Spare parts were scarce. Qualified armorers were casualties. Weapons that required expert maintenance became unreliable. The MG-42's sophistication became a liability. American weapons like the M2 that were designed for simplicity and robust construction continued functioning even when maintenance was minimal. This difference in design philosophy had strategic implications. German weapons were better in pristine conditions with full logistical support. American weapons were better in degraded conditions with limited support. And by 1944, degraded conditions were the norm. The ammunition logistics told a similar story. German 50 caliber equivalent weapons like the 13mm MG 131 used specialized ammunition that was produced in limited quantities. The 50 caliber Browning machine gun cartridge was produced by the billions. Multiple factories, standardized production, quality control that ensured reliability. The ammunition worked in all conditions: cold weather, hot weather, humid conditions, desert conditions. The powder formulation was optimized for consistency. Primers were reliable, projectiles were properly seated. American ammunition rarely misfired. German ammunition quality declined throughout the war as industrial capacity was degraded by Allied bombing and resource shortages. Post-war assessments by German military analysts consistently identified American firepower superiority as decisive. The official German history of the war in the West, compiled from 1946 through 1954 by former Wehrmacht officers working for the United States Army Historical Division, devoted extensive analysis to American weapons and tactics. The section on American machine guns was unusually detailed. It noted that German tactical doctrine assumed both sides operated under similar material constraints. This assumption proved invalid against American forces, who operated under fundamentally different constraints. The German analysts concluded that tactical excellence and superior training could not overcome material disadvantages of the magnitude Americans possessed. The 50 caliber machine gun was highlighted specifically as an example of a weapon that was not individually superior to German equivalents, but became decisive through sheer ubiquity and logistical support. The report noted that if German forces had possessed 50 caliber weapons in equivalent quantities with equivalent ammunition supplies, the tactical situation would have been different. But they had not, and by the time German commanders understood what they faced, it was too late to adapt. The psychological dimension received particular attention in post-war German analyses. Multiple reports noted that German soldiers by late 1944 showed signs of defeatism and fatalism specifically related to American firepower. Soldiers who were willing to fight and who had adequate defensive positions would surrender when facing American attacks because they knew resistance would simply result in casualties without affecting the outcome. This psychological collapse of the will to resist was attributed partially to the accumulated experience of fighting against American 50 caliber machine guns. You could not suppress them. You could not outlast them. You could not maneuver safely under their fire. The rational response was to surrender and survive. The legacy of the M2 Browning extended far beyond World War II. The weapon remained in American military service continuously from 1933 through the present day. More than 90 years of service. No other weapon system has achieved comparable longevity. The M2 served in Korea, in Vietnam, in Desert Storm, in Iraq and Afghanistan, in every American military operation for nearly a century. Some of the weapons currently in service were manufactured during World War II, 80-year-old machine guns still firing reliably. This longevity reflects both the fundamental soundness of the design and the effectiveness of the underlying philosophy. John Browning designed a weapon that was good enough for purpose and simple enough to remain effective under adverse conditions. American industry produced that weapon at scales that made it ubiquitous. American logistics ensured ammunition was always available, and American doctrine employed the weapon according to principles that valued sustained fire over conservation. The system worked in World War II. It worked in subsequent conflicts. It continues working today. The German experience with the M2 Browning in World War II taught lessons that influenced post-war military thinking globally. NATO forces after the war adopted machine gun doctrines that borrowed from both German tactical sophistication and American material abundance. The concept of general-purpose machine guns that could fill multiple roles came from German innovation. The concept of ensuring adequate ammunition supplies and emphasizing sustained fire capability came from American practice. Modern military forces attempt to combine the best of both approaches, sophisticated weapons employed with adequate logistical support. But the fundamental lesson remains valid. In industrial warfare, material superiority matters more than tactical excellence. A simple weapon produced in vast quantities and supplied adequately will defeat a sophisticated weapon produced in limited numbers and supplied inadequately. The M2 Browning was never the most advanced machine gun. It was never the fastest firing or the most accurate or the most portable. But it was reliable, ubiquitous, and supported by logistics that ensured it could fire continuously whenever needed. That combination proved decisive. German soldiers who survived the war and wrote memoirs or gave interviews consistently mentioned the American .50 caliber machine gun as one of the weapons they feared most, not because it was particularly lethal in any single engagement. Individual machine guns kill individual soldiers. The fear came from the cumulative psychological impact of knowing that every American position would have these weapons, that they would fire continuously, that ammunition would never run short, and that no amount of tactical skill or courage could overcome that simple mathematical reality. You were fighting an industrial system, and industrial systems win wars of attrition. The story of the M2 Browning in German hands is brief and telling. German forces captured many American weapons during the war. Some were used by German troops when ammunition was available, but the .50 caliber machine gun saw limited use by German forces despite its obvious effectiveness. The reason was simple: ammunition logistics. The .50 caliber Browning machine gun cartridge was not compatible with any German weapons. Captured ammunition was limited to whatever was seized with the weapon. Once that ammunition was exhausted, the weapon became useless. German forces could not manufacture .50 caliber ammunition in significant quantities. Their industrial capacity was committed to existing caliber systems. The few German units that did employ captured M2 weapons reported excellent results, but noted that ammunition scarcity made sustained use impossible. A weapon is only effective if you can feed it. The M2 required a functioning industrial and logistical system to maintain effectiveness. German forces lacked that system. This highlighted the fundamental difference in approach. American weapons were designed as components of larger systems: industrial production systems, logistical supply systems, training and maintenance systems. The weapon itself was just one part. German weapons were designed as individual excellence. Optimize the weapon itself. Assume the support systems would function adequately. When support systems failed, as they did increasingly after 1943, weapon effectiveness declined precipitously. The mathematics of attrition warfare are unforgiving. The side that can sustain higher expenditure rates eventually wins regardless of tactical skill disparities. The M2 Browning allowed American forces to sustain ammunition expenditure at rates German forces could not match. Each American infantry division could fire millions of rounds per month. German divisions fired thousands. The disparity was so large that tactical excellence could not bridge the gap. German squad leaders might be better trained. German soldiers might have more combat experience. None of it mattered when the Americans could fire 10 times more ammunition and sustain that expenditure indefinitely. This lesson has been relearned in subsequent conflicts. In Vietnam, American forces again demonstrated that overwhelming firepower could not guarantee victory against determined opponents using unconventional tactics. But the M2 remained effective in its intended role: sustained suppressive fire, vehicle defense, base security. The weapon worked as designed. In Iraq and Afghanistan, the M2 continued serving in roles John Browning could never have imagined. Vehicle mounted on Humvees, remote-operated turrets, base perimeter defense. The weapon adapted to new missions while maintaining its fundamental characteristics: reliable, simple, effective. Modern militaries have developed more sophisticated machine guns, higher rates of fire, better ergonomics, lighter weight. but none have replaced the M2 in American service. The reason is the same reason the weapon succeeded in World War II. It works. It works in all conditions. It works with minimal maintenance. It works when sophisticated systems fail. That reliability is worth more than marginal improvements in performance. A weapon that works every time is better than a weapon that works better sometimes. The German soldiers who faced the M2 Browning in World War II understood this instinctively. They were not impressed by American tactical sophistication. They were not awed by American individual marksmanship. They were overwhelmed by American material abundance and the systematic application of adequate weapons in overwhelming quantities. The 50 caliber machine gun became the symbol of that approach. Simple, ubiquitous, reliable, devastating in aggregate, even if not exceptional individually. The final assessment must be that the M2 Browning succeeded not because it was the best heavy machine gun, but because it was good enough, and there were enough of them. John Browning designed a weapon that met requirements without exceeding them. American industry produced that weapon at scales that made it universally available. American logistics ensured ammunition was never scarce. And American doctrine employed the weapon in ways that maximized its strengths while accepting its limitations. The system worked. German attempts to capture and understand the weapon yielded technical intelligence, but missed the larger point. The weapon itself was just one component of a system that integrated industrial production, logistics, doctrine, and training into a comprehensive approach to warfare. You could not replicate the weapon's effectiveness by copying the design. You needed to replicate the entire system. Germany lacked the industrial capacity, the secure logistics, and the resource abundance to do so. By the time they understood what they faced, the war was already lost. The M2 Browning fired its first combat rounds in the early 1930s. It fired its most recent combat rounds this year. 90 years later. The same basic design, the same fundamental operating principles, still effective, still reliable, still in service. No eulogy is needed for a weapon that continues fighting. The Germans learned to hate the 50 caliber machine gun because it represented everything they could not match: industrial capacity, logistical efficiency, systematic application of adequate force in overwhelming quantities. That hatred was rational, and it was futile. You cannot defeat an industrial system with superior tactics. You can only outlast it or outproduce it. Germany could do neither. The result was inevitable.